Hey guys, welcome to another tutorial. In this tutorial we're going to have a look at feeding text plus into the particle system in Fusion 8. The special thing here we're going to do is the fact that we're going to treat each individual character in a text string as an individual particle in the emitter. So you can have words where the individual characters basically act like particles because they are particles, right? In the standard usage of a text tool feeding into a particle emitter, basically we'll use the whole word or whatever it is as a single particle, right? So before we jump into the tutorial itself, let's have a look at a few examples. So first one up, some bouncing text, bouncing off a curved floor and fading out in the end. Then we've got a type of a movie or film credit example, scrolling in from the right, bouncing, falling and bouncing and such. Special thing here, by the way, is that this is all single composition, so it feeds in several lines of text and will all be dealt with automatically. Third example, and that will be the example we're going to recreate during this tutorial. It's basically text that will fall down and spawn off particles, subparticles that will basically create that trail you see behind it. So let's run it one more time. Rotating, and you saw the letters rotating and getting smaller, right? And then spawning of particles and then disappearing. And as you can see here, it's all subject to type of turbulence. So that's what we'll be making. So let's have a look at the finished composition. Right, so let's walk through the flow first before we start recreating it. So we start with the text plus tool where you can see the user enterable text, right? Could be anything. As a matter of fact, let's change it here to tutorial text. And as you can see here, that will now appear. Right? This will be fed into the emitter. A bunch of forces will be applied to the emitter, then it will be rendered, merged with the background. And as you can see here, by the way, the renderer here, particle renderer, is in 2D mode for this particular example. Other examples will work with the 3D mode, but here I wanted to keep it fairly simple. And then we merge it with a starry type background. We add a soft glow, and then we add a saver in to save it as a movie file. Right, so let's jump into it. Let's go to a new composition and let's add in a text plus tool, but with Control spacebar. Text, oops, not texture, text. There we go. Get it into viewport 1. We would have something like space text. The font we used was, let me have a little peek, intro inline. There we go. All right. I also want to size it up a bit. I will size it up a bit more because, as said, later on we will see the individual characters as individual particles. So I want to sort of maximize it here, but let's do that later on. First, let's work on making individual particles appear. Right. So if I would feed this into a particle system, it would just appear as one word. Basically what I want to do is for each frame I want to cycle through the characters until the word has been created and displayed by the particle system, and then it will be made subject to the forces. So what I want to do here is basically add in a new control. So I'll go right click on the text plus above there, do edit controls and create a new one. I call that text source. It will be a type of text, evidently. This is basically the page. It really means the tab where it needs to be displayed on this new control. Well, let's put it on the same tab here. That is the text tab. And the input controller is just a text box, text edit control. Hit OK, and then we've got the text source. Now this is actually the text we want to have as the source. Here, the style text, so the text that will be displayed, I want to have something like this, as, next frame, a, etc. right? So what I can do is basically add a little expression. So we'll be using an expression with a string function, string.sub. Sub, basically the string.sub function takes a string, right? It will be the first argument of this function, and then it will allow you to take a substring of that. The substring is defined by the first and the last character. So let's go for an example. I pick with this to text source. Pay attention here, I actually need to add the dot value with a capital V here, because otherwise it will not work. Don't know the reason behind it, but I just found out I have to do that. Right? Unfortunately, the information on these sort of simple expressions, it's not, there's information out there, but it's scattered about a bit. In any case, right? So if I want to take the first letter, basically say, okay, start at the first letter or character and end at the first one. And what you get then is the S. If I say take the first one and end at the second one, then I get SP. Right? If I just want to display the P, 2, 2. Right? So to make it appear, a letter appear each frame, all I need to do is basically include the time parameter. Right? Time 0 equals frame 0, time 1 equals frame 1, right, as indicated down here. So it cycles through it. Result here at time 0, frame 0, there's nothing because there is no such a thing as character number 0. So the first one will appear at frame 1, frame 2, the P, frame 3, etc. Now I want to take the opportunity to increase the size a bit. All right, let's make that 7. All right, and I actually want to add a little outline as we had in the example. So I'll go to the shading tab. You can see here this particular shader is utilized, but we've got a whole bunch of other shaders you can use, basically to add outlines, drop shadows and all that type of stuff. Some people may be forgetting about this, but it's very powerful and gives you a lot of flexibility. There are some presets for some of these, like red outline, enable it, and you see a red outline. Well, I want to actually have something similar, but I want it to be a type of blue. Let's make it this blue. I want it to be a bit thicker, and that looks pretty cool, at least in my mind. In any case, so that's the first thing. So we've got all these different letters coming in. Now all we need to do essentially is add in a particle system. So I've got a particle emitter and a particle renderer. So you can add this in via these buttons above, or as before, Control space bar and do emitter, right? Particle emitter and then renderer and such and such. Right, so let's display this in this viewport. Now what I do want to do up front already is set it to 2D, right, and merge it with a background. So add in a black background and oops, merge it in and display that there, right? So that's the first thing. So right now it doesn't do an awful lot yet, right? And I think, yeah, but let's work on that. Right, you see here these tiny dots, so that's the standard for the renderer. It will have a dot style, right? So if you go, sorry, for the emitter, if you go to the style, it will have a point. Right? I want to set it to a bitmap so that it can take the input from the text tool. So now I funnel the text in here, and what will happen next is basically, well, as you can see, it will generate a bunch of S's, then P, A, it cycles through it. However, I want the particles that have already been created or generated at a certain frame time, I don't want them to be updated when it gets a new letter fed in, right? So what I need to do is change the animate property to particle birth time, right? So it will just take the particle shape or that it got at birth, and it needs to be fixed at that. And now you can see first S and then some P's coming in, A's and such. Next thing I want to do is basically I want to decrease the number of particles. Each frame I just want to have one particle. Oops, change to 1. Alright, so at frame 1 get S, then P, A, C, etc. Now, of course, in the example, I want to create a word. So I need to do something with this. So I want to decrease the region. So the region right now is the sphere, that's like the emitter. If we decrease this, then you can see it all is basically generated from the exact same spot if it's set to 0. If you want to have a bit of variety, you can increase it somewhat, like 0, say 2 or 4. Right, then it's a bit offset, each character, but right, it is more or less from the same spot. So what I want to do is basically I want to create a word, so I can do multiple things here. I can either give the particles a velocity so that they start moving. For instance, I can get the S to, as soon as it gets created, it gets a velocity to go to the left, and then the P's following, etc., etc. In some examples, that's great. For this particular composition, I'm going to actually animate the offset of the actual region, right, where it gets emitted from. So I'm going to animate this X value. So, right, I'm going to animate it like so. I'll do that, however, with an expression. And again, I'll use the time parameter. As you'll see though, right, if I go to frame 1, it is way too big. It jumps straight to 1, then to 2, to 3, and it's way beyond the canvas. Right, so what I need to do is divide it by a certain value. You can calculate this value, right? But for now, I'm just going to eyeball it. So these letters are still spaced too far apart. So let's divide by 20. Oh, and also I want this to be going somewhere at the top. Still too far apart. So let's make this 40. A bit too much. 35. That looks pretty good. So if I now do this, then I've got space text. Right? I need it to be offset a bit to the left. So what I'll do is I'll take this value, put some brackets around it, and do minus maybe 0.1, maybe a bit more, 0.15. Okay, again, this can be calculated exactly, right? You can use the size of the canvas and such, but for now, let's, as before, let's just eyeball it. So this is good. This is the start. Right, so we will be doing something. We will be putting in an expression in the number parameter here, because essentially, even after the space text has finished, right after the T, you can see it's still moving. It is actually still generating invisible particles, and I don't want that. Now, in some circumstances, you will never see that. But in others you will, and I'll leave it for now just to illustrate the point later on. Right. So next one up. So we've got the renderer. I want this text to start falling down. However, you can normally give it, of course, a certain velocity, and you can give it a velocity of, say, 1. Well, maybe that's a bit much. You give it a certain velocity and you give it a certain angle, say minus 90, to let it fall down. Oh. Right. Issue here is that it starts falling down straight away as it gets generated. The S gets generated first, it starts falling down. That's not what I want. Now, some people may be inclined to start animating or keyframing the velocity parameter. Issue is, however, that the velocity parameter is only affecting the particles that are generated at that point or later on. So if I've got a velocity of 0 when the S gets generated, and later on, say at frame 50, we're going to increase the velocity to 1 or to 0.2, it won't affect the particles that have already been generated. So for our purposes, we want the text to be displayed first, we wait a bit, and then it starts falling down. We can't use this. So let's set this back to 0. This doesn't really matter, but let's set it back to 0. Instead, we're going to make use of a directional force So P directional force. As you can see, it takes effect straight away. It has a standard direction of -90, i.e. going down, standard strength of 0.1. But as before, it would have affected the S earlier on because it was created earlier on. However, as opposed to the velocity in the emitter, in the direction of force, it will basically affect all particles, right? Whether they were born already or not. Right, so I can keyframe this. So let's do this. So at keyframe 50, so let's go to 50, or ish 50, animated. Next one up, 51, set it to 0.1. And that's it. And then we won't touch it anymore. There we go. Now, as you can see, all the letters start falling at the same time. I want that not to happen. I want them to sort of be, some should fall earlier than others. Now, I can do this by changing the probability in the conditions tab. Essentially, this means the probability that an individual particle will get affected by this force for a particular frame. So if I say that, set it to approximately 25, means in 25% of the cases, 1 out of 4, an individual character would be affected by it. Right, so that essentially means they won't all fall at the same time. So if we play this, there we go, and that's what we want. As you can see, it starts fading out at the end here. I want to ensure actually in the emitter that the lifespan of the particles is a bit higher. So let's set it to 225 or something. Right, we can tweak it later on anyways. So effectively, we've got now the direction of force, which is great. Right. Next thing we saw was basically that we want to have a bit of turbulence in it, right? So that the characters start waving a bit. Well, as you may expect, we add a P turbulence in here. Right, and as you'll see, it starts affecting it straight away. Again, we could keyframe it. However, there's another way of doing it, and that's by introducing a region. And the region basically affects the scope of where this force would be effective. So go to the region tab, say when inside that region, then only let it be affected. So I'll create a rectangle. As you can see here, nothing is affected. As I move this rectangle over the word, it starts being affected, right? So only if it is inside that region. So I want to place this just underneath. As you can see here, this is sort of the cutoff point. That make it a bit wider. Unfortunately, with the height, it works this way, right? So I need to scroll down a bit again, sort of do this, and now you'll be able to see we get what we want. All right. There's a slight wave in the particles. Okay, next one up. We want these subparticles or these trills to be created, and we do it with the spawn function, the spawn node, p spawn. Right, and let's have a look here. What starts happening? And this is where we've got to be careful. This is what I meant earlier on. We have got a number of invisible particles, yet for fusion they are there. They're just invisible. We don't want particles to be spawned of invisible particles. Right? So what we need to do is go back to the emitter and basically ensure that it won't generate a particle if there's no input coming from the text tool, i.e. if it is empty. So how do we do this? Well, first of all, let's pin this. Right, so I select this tool, pin it. So that means if I now select another tool, it will still display this so that I can actually use the parameters and variables from there. So I can, in After Effects terminology, pick whip to them. So go to the emitter and add an expression here. Basically what I want to say is if it is empty, right, or i.e. if there's no input, then don't generate particles, i.e. set the number to 0. Otherwise set the number to 1. Similarly with the space, like between space and text, there's a space, like a space bar. For that as well, I don't want to generate a particle, so the number should be set to 0. So what I'll use is an if condition, or an if statement. You can do that in different ways. Generally speaking, these expressions work with Lua type syntax. But in any case, this is the most straightforward way of doing it. So if with double I, open brackets, put in the condition. So now we're going to pick with this to, oops, it was on the text tab, and then the styled text, again, dot value with capital V, if that is unequal to, and you do that with that little wiggly thing, oops, little wiggly thing, and the equal sign, so wiggly thing, equal sign. So if it's unequal to an empty string, right, then it basically needs to generate a particle, so a 1, otherwise 0. So as you can see here, trill's gone. We're still left with trill here in the middle, so we want to tackle that as well. So we also want to tackle the space. So all we do here is copy this over, this bit here, copy, and say, and if it's also unequal to, we have had the empty string, and then we make it, put a space in there. So if it's unequal to empty and unequal to space, then do this. And if we then enter it, you can see it disappeared here as well. Right? And now we end up with this. You notice here there's a little glitch. And this, you will see, happens from time to time. Sometimes this is due to, I don't know, a miscalculation of some kind. It helps sometimes to restart the calculation. And in this case, it did. Right? Sometimes I just need to tweak a parameter and tweak it back to the original value. It's just one of these things. You will encounter it. Don't worry. As you're tweaking along, it will go away eventually. Right? So as it did over here. So going back to piece 1, let's have a look again. And now I just want to see it in the merged background. Oops. Oh, as you can see here, by the way, in my merge tool, I had the background as the foreground and the particle system as the background, right? The yellow one is the background. This is the foreground, the green one, or the lime green one. If you want to swap that over, do Ctrl T. Right? Now the background is the background and the particle renderer is the foreground. So if we play now, we can see this properly. Right? Now we see a few things here. First of all, these particles underneath. We need to change 2 things to make them go away. So go back to spawn. First of all, the velocity controls. I don't want any velocity to be transferred from the main particles to the spawned off particles. So do that. Secondly, I want to ensure that the directional force we had is only affecting our characters and not the spawned off particles. Now, the way I do this is by basically saying, okay, you've got the conditions. Here you can see ignore sets and it's not doing anything with it. Or you can say, okay, affect specified sets. Now, if you run it, nothing is happening because the directional force is not doing anything because none of our particles have been set to any of these sets. So if you go to emitter 1, so the main particle system, if you go to sets, right, nothing has been specified, sorry. So if we set this to set 1, then you can see and this is what we want. Now, for the spawn particles, wasn't set to any set. If we want to treat it individually later on differently, we can give it a different set. Right. with set 2. Oh, actually something is not quite right. Go back. Oh, sorry. Set 2 should, we set that as set 2, and we don't want set 2 to be affected. There we go. So again, I messed it up a bit, but effectively we're saying the spawn particles are part of set 2. The original particles, the characters, are part of set 1. And then the directional force is affecting all sets apart from set 2. Now the other ones are not important because we didn't assign anything to them, but essentially apart from set 2, which is the spawn of particles, so they're not affected now by the directional force. And now that is what we want to see. However, there's one other thing you may have spotted, right? In the spawn, it gives you like 10 particles each frame for each affected particle, or for each affected main particle. Now, I would expect to see more particles based on this, but I don't. Now, the reason is that there's no position variance. So a lot of these particles are actually born or spawn to the exact same position as each other. So basically they're overlapping or they're completely obscuring each other. So if I give it a bit of variance, there I see the rest coming in. And now we see more particles. You see something peculiar happening here. Again, these are the ones spawned when the letters were, or the characters were just hanging about there. I want that to happen just below so that you don't have these somewhat static ones here. So what we need to do is do the region thing again. So when inside region, define a rectangle, increase the width and the height, and ensure that it is just below the text. So the text was about here. So I wanted to start to say, well, this is about alright. So if we now play it, this is more like it. Right? So the thing we did in the example video is we had actually a different input, to the spawn. So again, we didn't want to use a point particle, but a bitmap particle, and I want to use a fast noise for it. So what I'll do, set a style from point to bitmap, and then create a fast noise. This doesn't need to be big, right? So I set it to 100 by 100. We're talking about tiny particles. This is even still too big probably, but in any case, let's leave it with this, right? Display it here, and then add an elliptical mask like so, and give the soft edge maybe even a bit more, 0.5, right? And pump this, into the spawn. Right, so like so. So what we see now, right, if we zoom in a bit, right, these are much nicer. And that is almost equal to the example we'd seen. So we're getting there. Right, so what I did in the example as well is I want these to fade in a bit. So when they get born, I want them to be more transparent. So again, in pspawn, in style, fade controls, fade it in. Right, so as if they're sort of darker at the start, so they fade in. I also played around with some of the merge controls and tweak it a bit. I won't explain the exact effect here, but you can see it has an effect. Now we can play with the colors a bit. Let's give it a base color of a bit reddish or orangey, right? And then let's introduce some variation. And this is really just for me right now playing around a bit. For now, I tend to do this a lot. I'm eyeballing it a bit. Right, I want to have maybe purpley. Let's do something like this, right? And now we've got this effect. Right. Now there's only two things left to do, right? We want these characters, right? The individual letters to start rotating and to become smaller as they pretty much enter this box as they go down. Now, I had to do a bit of research on this, but I found out it is best to use a custom particle tool for this. And that is this particular one. Right. I won't go through all the details. As a matter of fact, I don't understand all the details, but I found out a few things. This tab here, the particle, here you can basically affect some of these particle properties. Now the one thing I want to affect for certain is the size. So basically I want to say each frame, as they enter a certain region, right, I want them to become smaller. So basically I'm saying minus 0.0, maybe 0.8. Something happened here, and I can explain that. What you saw here, when I increase this too much, it means at a certain point it becomes less than 0, and then basically what happens is if the size of this is particles less than 0, it flips over. So it's sort of like the mirror image. So what I can do is introduce a little function called the max function. So I take the max out of this, comma 0. So essentially say take the maximum out of this and 0. So if this is below 0, the maximum will be 0. Essentially this is like equivalent to a conditional function where you can say if it is smaller than 0, make it 0. And now essentially you can see it gets small really fast. Now first of all, this is way too fast, right? So we can make it 002. And also we don't want this to take effect until it enters the region, right? So, oops, my apologies. Region, when inside the region, we make this a rectangle again. We make it wider, higher, and oops, move it down a bit. Something like this. So let's have a look now. Look at that. That's what we wanted. The colors are a bit dark for me, so I do want to maybe something like this. Now, final one, and this will be, well, almost the final one, change the spin, right? So we saw in the example, right, they're falling down, getting smaller. In the original sample, they were spinning as well. So what we want to do is change the spin Z expression, or Z, depending on where you're from, and make that dependent on the time, maybe time divided by 2. Let's see what that does. Way too fast, right? So let's divide it by 4. Much better, right? So essentially, this is the effect we were going for. You can tweak an awful lot, right? If you think, oh, this is not quite turbulent enough, well, let's increase some of that turbulence. Let's increase this X strength by a bit. And let's have a look now. See, that's quite nice. Lastly, the last thing I did was add in a glow, soft glow, and let's see how that affects things. See, that's way too much. So let's decrease the gain somewhat. And there we go. The final effect is here. Now, I hope you guys enjoyed this tutorial. More tutorials are planned. If you've got any questions, any comments, please leave them below. And well, see you next time. Thanks very much, guys.